All right, so everybody, welcome back to the last day of Swimmer School 2022. And today it is my absolute pleasure to introduce today's speaker, which is Sarah Chasins. Indeed, one of us who we all ganged up on and forced her to be our fourth speaker. Not entirely against her will, but in a total surprise. Now, Sarah is an assistant professor of computer science at UC Berkeley, and among many, many cool awards is a Chan Zuckerberg BioHub Scholar, which I just learned about today and is such an awesome thing. And on a personal note, I've known Sarah since we were both students, and she's one of the people who really inspired me to take up this very finicky direction of working HCI into my PL work. And her synthesis work has been some of the most inspiring to me personally. And I've been really fortunate in my personal career to always have her walking about 2 steps ahead of me and paving the way to get all of the PL conferences to be ready to look at the kind of work that we do, so that by the time I got there, you know, everything was a little easier for me. So thank you, Sarah, for that.
You're sweet. You're really sweet.
So we have do we have a questions for Sarah channel?
I can make one now.
It's already.
It's
Well,
already.
maybe I didn't announce it in the Slack since I'm not on the Slack too. So.
Oh, sorry.
All right, I'll do that.
Sorry.
So I'll do that on Slack, and so ask questions on Slack, and we will interrupt Sarah same way as we did yesterday. And Sarah, over to you.
Thank you so much. And please do go ahead and interrupt in the Slack. I love to have this be more chatty. I've already put chatty in the title, so you know that I really mean it. So hello, everybody. I think I have actually introduced myself to most of you by now, but it's really great to see everyone in sort of this separate role as speaker. To give us a bit of context, I'll give a very quick description of sort of the kind of work that we do in my lab. I'm incredibly lucky to have a really amazing group of students with very diverse range of interests. But one thread that runs through a lot of our work is actually building programming languages and programming tools that work for novice programmers, and even actually for people who would consider themselves to be non-programmers, would describe themselves as non-programmers. So this is journalists, social scientists, lawyers, even recently biologists. So in contrast to something like the talk yesterday, we're really not dealing with folks who already have a warm emotional attachment to a given language or a given environment. And we're looking at what it takes to make languages and abstractions that are easy to learn and not just easy to use after a long period of developing the expertise. So today we're going to very casually talk through the story of how we figured out some really interesting lessons about synthesizer learnability. And with that, I'm going to have us dive in. So this really is going to be mostly a story time chat. We're just going to go through what happened, you know, how are we making the decisions, what were sort of the research design points where we stopped and said, okay, what's the right thing to do here versus here? And then when we hit a research design or process decision question that I think is actually especially interesting or that is worth sort of following up on why we did that, I'll pause and I'll go ahead and expand. Okay. So I now want to introduce us to, not me, my intro was amazing, thank you, Hila, but the stars of the story, which is Justin and Danya, who are the students who actually did this work. So they're the ones who are going to be doing all of the heavy lifting here in the story that remains. So if you want to see the very official version of this talk that looks like a standard conference presentation and actually covers this work in a more traditional way, do go ahead and take a look at it in actually this year's list. It will be presented there if you want to see sort of the formal version. Okay, so the plan for today's talk is to cover basically 2 studies. So there was one study that inspired a lot of the work that eventually got published at UPSLA, but really actually we're probably never going to publish on that study. It was really interesting. It taught us a lot of really useful lessons, and we were going to dive in on what exactly was happening in that. But then I'm going to move on afterwards to, okay, then what happened? Why did we drop that stuff? Why are we probably not going to go ahead and actually publish that stuff? And then what did we decide to do with the information we learned during that, leading to a study that we eventually did publish? Okay, So our research question for the first study, the one that is probably never seeing the light of day, except maybe in this talk, is does synthesizer use improve student learning outcomes? So I do want us to talk about why this question, but I first want us to back up for a moment and talk about what actually is a synthesizer. So what is program synthesis? Basically, the idea is, say we have a particular program in mind, but we don't want to just sit down and write out something that looks like traditional code that would actually get us that program. Instead, we have sort of a specification in mind, right? Something that relates inputs to outputs. And if a particular program meets that specification, we know it's the program that we want. But maybe we're a non-programmer, a novice programmer, and we're not actually ready to write down the code that's going to implement that. But maybe there is actually a way for us to write down the spec. And so this is the kind of case where we might want to use program synthesis. So for ease of use, for productivity, when it's actually going to be faster or easier to write the specification rather than actually writing the program directly. This can also actually be useful for correctness, although I won't really be touching on this as much in today's talk if you just find it easier to actually prove the specification rather than to prove the program. So these are the kinds of cases where we might want to use synthesis. I know this was a little bit, oh yeah, sorry. So there's our correctness condition over there, our spec, and over here we have the program. We want to find whatever program actually meets that correctness condition. I know that was a little bit vague, so let's get a bit more concrete about what this kind of looks like. This is the most famous program synthesis tool that is out there, and this is actually probably available in whatever version of Excel you are running on your own computer right now. So here's the idea. We have sort of this column of information on the left, that is our inputs, and then over on the right is where we want the outputs of running our program to appear. And so say that for one of these cells, we go ahead and put one of the outputs that we expect in there. Then our specification is just that input-output pair. And we know we want a program that maps the input to the output. Flash fill behind the scenes when we run Control-E figures out a plausible program here, which is to put the text prof in front of the last, or well, the second word. Well, actually, no, the last word as divided by spaces or dashes. I'm looking through the actual examples to figure out what it actually figured out here. And so we can see, okay, it didn't quite get right there, right? So we've got Kelly instead of Ragging Kelly, and it seems to have tried to generalize to that title bar there, right? We have prof name, which, okay, we probably didn't want that, but hey, that was a good guess. And so, it has figured out something from this input-output example about the kind of program that we might want, and it has gone ahead and actually run it for us. Okay, you may be saying to yourself at this point, hey, I've seen this kind of thing before. I am giving the computer some kind of high-level description of what I would like it to do. And then what's happening is the computer is giving me back a low-level program to do it. This sure looks like compilation. And this is a very reasonable thing to think and to try to get at what is the distinction between this program synthesis thing and this compilation thing. I'm not really going to be trying to hammer home a particular difference, but you can think of these things as being on some kind of a spectrum, where over here in compilation land, we're probably doing some kind of a deterministic process. We're doing a series of lowerings in order to actually get us from that high-level thing down to the low-level thing using probably some kind of rewrite rules. And then over here in synthesis land, we are probably doing something that approximately looks like search. Maybe we're searching through programs. We might also be searching through a sequence of rewrite rules, which starts to make it look more like compilation. But basically, this is sort of the two ends of the spectrum, and there's a lot of stuff in between. And somewhere in here, we draw a line. We may not have sort of a hard dividing line, although some people will enforce one. But for us, it's not that really that useful, and we're happy to just have this be a fuzzy distinction. Okay, so why synthesis? Why are we actually bothering to study synthesis in particular? So basically, this is one of those things that just seems to keep coming up, especially for people who are trying to bring in programming languages techniques into a space that is more HCI. It just seems like we end up continually wanting easy ways to write programs based on something that doesn't look like traditional program text. And so this is something that we're seeing again and again. And there are a lot of different PL techniques that do tend to keep coming up in HCI tasks. So things like structure editors or program slicing, these kinds of things come up as well. But for whatever reason, synthesis is one of the ones that just comes up quite frequently. Okay, back to that research question. And now we can dive in on why are we asking this particular research question. So does synthesizer use actually improve student learning outcomes? And basically what was happening was at the time we planned this project, we were seeing all of these claims about the possibility that synthesis would help in education. And in particular, that it might help students learn or understand better, especially a language that they hadn't seen before, right? So maybe it's something where, okay, they're writing a program in a language they already know, and then that is being used as the specification to give them back a program in a language that they don't yet know. There are all these ideas that these could help us actually understand or learn better. But unfortunately, we had not actually seen. Yes.
Sarah, I'm sorry. Because I guess haven't seen some of these claims. I'm still struggling to understand what the actual claim is that was in these papers. And was it actually a crisp enough claim? I just don't see synthesizers as improving learning outcomes in any way at all. So I'm just baffled by the claim at all.
Yeah, so we were also finding it quite confusing, I have to admit. So it wasn't something where we were actually seeing it as, you know, the claim in the eval or that kind of thing. We hadn't seen it, you know,
No, this is what you write in the second paragraph of the introduction to
exactly
how awesome synthesis is, right?
Exactly. This was in the motivation section. This was in the introduction. This was saying, hey, you know, like, let's put these synthesis tools in educational contexts, and maybe this is going to actually improve learning. Yeah, definitely not something that had been evaluated. Which is sort of why we found it weird, right? We were like, hey, we haven't actually seen any evidence of this. Why is this a claim that keeps circulating? What's going on? And so we dove through a bunch of literature, basically trying to see if we could find any evidence that this had actually been evaluated, that there was a reason to propose this idea. And this is approximately the literature that we sort of scanned through. And we just didn't come up with any luck. We didn't find anything that actually looked like evidence of, you know, this kind of effect of using synthesis, which, you know, as Hila mentioned, I actually am very much a synthesis person. I would love to find out that program synthesis does in fact improve learning outcomes, but I just was a little bit skeptical of this claim, or just hadn't seen any evidence of it so far. Okay, so we're gonna quickly go ahead and open our chat box and say, what would you do to answer this question? How would you check for yourself if synthesizer use improves student learning outcomes?
Do you want this in Zoom chat, right? Because you want to see immediate answers.
Yeah, I'm going to encourage you to think about it for 30 seconds and then throw something in the Zoom chat so that I can see it just real quick and scan through. Sorry, thanks for the clarification. The idea is, if we wanted to design a study that gives us some evidence about if it does or doesn't help, what might that look like? Definitely want to concretize, yep. Pre and post test, love it. Yeah, so I think these ideas are basically getting at the kind of stuff A/B test, yes, exactly. And so another way to say that probably would be, you know, a randomized controlled trial, right? So we were hearing about those, I guess it was Tuesday, right? And so here's how this, you know, basic setup tends to go, right? We have a bunch of participants. We're putting them in based on whether they go through a screening survey or are the kinds of participants we want to be working with. We ask them for informed consent. We gather interesting demographic data about them, and then we assign them to a condition, either the control condition or the experimental condition, right? And so in our study, the one that we had was, okay, we're going to go ahead and put a particular lesson here as the control condition, and then the lesson augmented with use of a synthesizer as the experimental condition. And we were thinking, okay, in one condition, they're going to get this sort of online lesson page, which is going to teach them about binary search trees, actually, was the topic that we chose. And in one condition, they're going to get an online lesson page with the same lesson, but also with using a synthesizer. And then all we have to do is figure out if that actually improves the learning outcomes. Now, it is actually pretty tough. Please.
Can I ask?
Please.
I'm sorry. I feel really dumb. I still don't understand. So they have a lesson. So are they being asked to write code for binary, sorry, you said binary search tree, is that right?
Yeah, so in the condition where they were in a lesson, they were going to go through sort of the teaching materials, which was just a web page, and then we were going to ask them to write out. I'm trying to remember what the actual
some insert or something like that. Okay, fine.
Exactly.
And in the other one, they'll read some materials, but also use a synthesizer to generate the code for insert.
Exactly. So in either case, they're going to end up with code for insert or whatever it actually was. But in one case, they're going to have just written that out manually. And in another case, they're going to have given a specification in a tool that I'll show a screenshot of later.
And you do something to normalize time on task sorts of things.
Exactly. Yes, yes. We did actually also analyze whether it changed time on task, but we're not even going to dive in on that in this talk.
Is it okay to question why this has anything to do with learning outcomes?
Yes. So that is sort of the next thing is, No, I love that. I love that.
Yeah. Yeah. Thanks.
Okay. So here, let's move into exactly Shriram's question. What are we going to do about learning outcomes, right? So we're seeing one version of this lesson with no synthesizer, one version of this lesson with a synthesizer. In one case, we're writing code manually. In one case, we're writing code with a synthesizer. How do we actually check if there's any difference in learning outcomes in these two conditions? And again, I'm going to ask you to go ahead and pop any ideas you have in the chat. Okay, I love it. I love it. Yep. Yep, let's do some testing after. Let's do some interview. Okay, I love it. Yeah, and so basically the risk here is, say we just design, so testing learning outcomes is really, really hard. And there are other people on this call, including Shriram, who would be much better to talk about why it's so hard to actually assess learning outcomes. But the risk here is, if we design a question about topic X, who is actually going to tell us that that is a good way to actually measure student learning? This is an incredibly hard task. And maybe we will write a question where students that have a particular set of misunderstandings will still actually be able to get the right answer, and then we've measured it wrong. Or maybe we're going to write a test where students who actually do understand X are going to be able to do it, but then some other misunderstanding about Y is going to get in the way, and then we're again assessing their knowledge wrong. And it's just on and on like this. There's so many different ways of running into this kind of problem. And so avoiding this kind of issue is incredibly, incredibly hard. Now, we do have some tools in this toolbox, in particular the idea of a concept inventory, which is basically a validated test for, do students deeply understand concept X? And in particular, the reason we chose binary search trees was specifically because there was a concept inventory in that space. We unfortunately do not have very many in the computer science space. Last time I checked, I believe there are still only 2. Others can probably jump in.
It's complicated. Let's not talk about it.
Complicated, fair enough. Yeah, not deeply important to this story. Okay, so here's our status at this point, right? We have a plan for showing some participants a lesson and other participants the same lesson, but using a synthesizer instead of manual programming. And then we have a way of measuring student understanding before and after the lessons. So now's a good time to jump in the chat. What are we missing? Are we missing anything? I'll give you the spoiler alert. We are missing something. Time on task for sure. We definitely want to be measuring that. The actual design of the synthesizer, definitely. Yeah, I'm going to gloss over that pretty hard in this talk. We're not really going to talk deeply about the synthesizer. The lesson itself, we definitely need to make sure we actually trust that that is a useful lesson. Student learning how to, yes. So how will they be able to actually learn how to use this synthesizer? I love it, Kim. This is great. Okay, so we actually also identified one other gap that we really wanted to think about, and it relates to what you said in the chat about the actual design of the synthesizer. So here's just a quick screen grab of what that sort of specification creation interface looks like. Does this give anyone some ideas for another gap that we might have right here? It's okay if not. I can jump ahead to the answer here. One of the answers here. There are many plausible answers here. What does return mean? Yeah. So I'm not going to dive deep on this UI. Yeah, how students are interpreting the UI, that is definitely going to turn out to be an issue. 100% multiple interfaces for testing, which is the best. I love it. Okay, we actually thought of something a little bit different. So we figured out to add a third condition because maybe just giving the specification was actually something that could help students, right? Say, the synthesizer itself might not actually be doing anything, right? So seeing that code instead of writing it manually, seeing it as generated by the synthesizer, maybe that doesn't help. But maybe going through that process with this funky little interface where you're sort of working through how to navigate a particular tree and you're actually thinking about it in the context of a concrete example, maybe that actually helps. And so we went ahead and added basically a third condition where we still have that same lesson and we still have that same synthesis interface where we're actually doing the creation of the specification, but we don't actually see the output from synthesis. And we thought that's going to at least help with a little bit of the sort of difference in an interaction. Okay, so let's actually see our results, right? We're going to gloss over what exactly that lesson looked like. We're going to gloss over exactly what that synthesizer looks like. But what actually happened? And so basically, no effect. Spec creation interface, that didn't boost learning. Synthesis outputs, that didn't boost learning. We didn't see any change in the learning outcomes based on adding these interventions. So this is kind of an interesting decision point in this research process at this point, because there are some interesting things that we could do, right? So one thing we could do is go ahead and actually push to publish this negative result. Negative results are really useful, and communities can definitely benefit from them. In fact, in this case, I personally was basically expecting a negative result. I didn't really expect to see that synthesis was going to improve learning outcomes. I would have been a bit surprised to see that. It would have been very interesting. I'm a big fan of synthesis. It would have been cool, but I would have been surprised. And so I think this is actually something that would probably be useful for the community to know. And so it would be very interesting to go ahead and actually push to publish this. Another thing we could do is actually follow up. Let's diagnose why the result was actually negative. What was it that caused us to see this outcome? Let's try to design other studies that can sort of follow on to figure out a bit more about this result and why we saw this result. Another thing you could do if you're like really keen on getting a positive result instead of a negative result is try to think up some other way of investigating the same question and think, will there be some way that we could get a positive or easier to publish results? That would be a plausible path. I find that one a little unsatisfying myself, but you know, this is not something that never happens. And maybe there are some other paths as well, but these would be some possible paths you could follow. I want to stop briefly here to talk about publishing negative results because I think it's a really interesting topic. So negative results are actually incredibly interesting and can save other people in your research community a lot of effort. And so it's actually really valuable to have negative results out there, even for something as simple as, you know, I tried this technique for doing, I don't know, I tried algorithm A as opposed to algorithm B, and algorithm A was no better than algorithm B. Like, that's really interesting if that was a good idea for an algorithm, because it saves a bunch of other people from a bunch of time. If they figure out, oh, don't do it that way, it seems like a good idea, but then it doesn't actually pan out. Now all the other researchers don't have to do that same experiment and figure it out in the same way. And so negative results can be incredibly interesting and incredibly valuable. And so we did consider this path quite seriously. And in fact, several of us did really expect that this would be the outcome from this study. However, it is also true that publication venues tend to be, in my perception at least, still fairly resistant to publishing negative results. And so it probably would have been a bit of a fight to do this. And, you know, we had a student on our team who was a master's student who was pushing to get her publications out before she graduated. Like, there were some sort of, you know, practical everyday concerns involved in deciding what to do with this information. But then the bigger thing, even more than how much of a fight it might have been to actually publish the negative results, was, you know, having seen those sessions got us sort of thinking. And in particular, Danya and Justin, the stars of the show, were thinking. So they were actually watching these sessions, going through the sessions from the previous study. And they were thinking to themselves, this is very interesting. It seems like this interaction model is actually super hard for users to learn. And so then we're starting to ask ourselves, okay, you know, there are actually probably multiple possible explanations for the result that we saw. So one is, okay, synthesis isn't automatically helpful for learning outcomes. That wouldn't be a surprising result. But another possibility here is difficulty with actually learning this synthesizer could have just gotten in the way. It is very plausible that this is what is actually going on. And so we stepped back for a sec and we asked, had we followed best practices for actually making the synthesizer learnable so that it wouldn't get in the way, so that it wouldn't end up sort of skewing the results we would see? And this is quite an interesting question because there kind of aren't best practices for designing easy to learn synthesizers. There just aren't really a ton of guidelines out there for that kind of thing. Yeah, so what best practices? What do we follow here? And so this was kind of the turning point in our research process here. We were thinking about how we kind of skipped too far forward on this research path. And really there were a few other stops along the way that we figured someone should visit to make the project more informative. And why not us? So basically we were saying, okay, well, what's the deeper issue? Figuring that some of it was a first use thing, and did they even know how to use the synthesizer? How do we even know? Has anyone even figured out what it takes to make one people can just pick up and use? And since no one has written that study, this got us interested in saying, okay, let's back up. Maybe we're not even ready to run the learning outcomes study. We still have to figure out what it even takes for someone to be able to pick up a new synthesis tool. Let's figure that out. So synthesizer learnability became basically our new focus rather than synthesis's effect on learning outcomes. I know we're using learning in both of these terms, so let me back up for a second, just really quickly say. So synthesizers and their effect on learning outcomes, that's really looking at, is it affecting student education? Is it affecting student understanding of topics? That's what we're talking about when we're saying synthesizers' effect on learning outcomes. When we talk about synthesizer learnability, what we're saying is how easy is it for users to come in and upon first seeing the synthesizer, how easy is it for them to start doing tasks and accomplishing things and doing what they need to do? So that's what we mean when we say synthesizer learnability. This is probably a pretty good spot to pause and ask if there are any clarification questions or anything like that. Okay, I'm going to assume we're good, but if it comes up,
there's a question that came up in Slack right this moment.
Awesome.
Which is, Matt is asking, how does learnability change with the background of the students? So for instance, was this in an intro class?
I love this question. Yes. So learnability can vary dramatically based on prior experience of the user and prior experience with a lot of different things, right? So it can vary based on prior exposure to program synthesizers. It can vary based on prior exposure to programming in general. It can vary based on prior exposure to whatever kind of topic you are asking them to discuss when they are developing a specification, right? So there are all kinds of things that can affect how learnable a given synthesizer is upon first use. We are going to be focusing specifically on novice programmers, and I think specifically we filtered for folks who had taken exactly one computer science course. So one semester, and it was a particular course at a particular university. So it was a fairly uniform set. This is not to say that this is going to be the same lessons for usability or learnability for every other audience that is out there. Very good point, very good question. Anything else there before we keep moving on?
I guess I just feel like we are no longer at all talking about the original question, right? We're not
100%
improving education. We're really talking about like a evaluation of a tool.
100%, yes.
In any setting, it just so happens it's being done with college students because that's your available population or something.
Exactly, yes. So the old research question has now been dropped on the floor, right? Yeah. We were going through that process. We were looking at the sessions and we said, you know what? Like, we were not ready to ask that question at all. That was too soon to be asking.
Just to be 200% clear, we're not actually addressing the thing that motivated the research, that was the claims in the papers that you saw. Got it. Thank
exactly. You. Yeah, everything about the question of, are we going to affect learning outcomes? We're not going to touch on that again throughout the whole rest of this talk. That was part of our process of getting to this research question. It was by asking this research question that we got really excited about our new research question. But now we have, you know, we could just cross out learning outcomes, and now we are only talking about, I don't know if you can see my mouse. Now we are only talking about what makes synthesizers easy to learn.
I can sign off now. Thanks. Bye.
Exactly, yes. So this is where we reach our turning point. We cross out the one we didn't publish and the one with the old research question that we had previously introduced. Now we're talking about the one that we did actually publish, which is on a very different topic. Okay, so back into our Zoom chat, very, very quick thoughts. What would you do to answer this question? What makes synthesizers easy or difficult to learn? This is cool because I'm not seeing answers coming in, which I think means it's harder than the last time we asked this question. Different synthesizers get their feedback, love it. I even see the number 5 called out, which is going to be relevant. Studies to figure out, yeah. Watch someone try to figure out, I love it. Usability heuristics, I love it. Dimensionality, and use multiple synonym pre and post, yeah, I love it. Okay, so this is great. So a lot of what I'm hearing here is, let's do some observational research, which is an answer I love. So let's see. Oops. Okay, there we go. So we've talked over the course of this past week about a number of different axes in experiment design, right? So these are all ones that we've touched on over the course of this week. We've talked about sort of how expensive it is to actually do the engineering work involved. Are you going to be just drawing out an interface on paper versus are you actually implementing the system first? We've talked about the data collection approach that you might use. Are you putting out a survey versus are you running an RCT versus are you, sitting there and watching users as they do some stuff? We've talked about the data analysis approach a little bit, not as much, but in particular the fact that usually you're going to be using statistics to actually evaluate a randomized controlled trial versus you might be doing something else for other things. I want to actually introduce us to thinking about one more axis. And this is basically about the kinds of questions we could be trying to answer, right? So one of the things you want to be thinking about when you are designing a user study is what is sort of the category of question that you're actually trying to get a research answer to. And I'm going to roughly group these into three. I think this is a fairly standard grouping, so I don't think this will be super surprising to the folks on this call. So if we're categorizing according to research question, we might be doing need finding work, which is basically just asking ourselves, what is an interesting problem to solve, right? Say we haven't even gotten to the point of picking a problem yet. We don't even know what is the thing for which we should be writing tools or writing languages or whatever it is. What would be a good thing to be our actual goal? And then formative research, with formative research, we've already picked a problem, and we're trying to sort of feel out what is a promising solution? How does A compare to B compare to C? Or what can we do to actually get some idea of what would end up being a promising solution to this particular problem I've solved? And then over here at evaluative land, this might be the kind of user study that you are used to seeing. And for a lot of people, when they first start integrating HCI, yeah, go for it.
Sorry, no, when you're done, there's a question in chat, that's all.
Oh, sounds good. Okay. And then for a lot of people, when they're first starting to integrate HCI into programming languages context, they're mostly thinking about evaluative studies. And they're thinking, okay, we've got a problem, we've got a solution, let's just see if that solution actually did solve that problem, right? Like now that we have implemented something, did it actually work? And these are all three fairly different kinds of questions to ask, fairly different kinds of studies that you want to run based on knowing which category that you fall into. Okay, there was a question.
Yeah, it's a great question from Bhakti, basically asking, like, what is a synthesizer, right? Because there might be lots of different notions of synthesizer. And then depending on which one, like you might get incomparability, et cetera, et cetera. You can see where this is going. Yeah.
Yeah, I love this question.
Yeah.
And so one of the things that we're hoping to get out of this study, and we'll sort of circle back around to this a bit, is sort of understanding what are even the axes along which synthesizers can vary, and how do those end up affecting the learnability of the synthesizers. We're not even going to get into how they affect the usability of synthesizers long term for someone who's an expert. So this is actually something where even characterizing that space of what are the design decisions that you can be making as you are developing a synthesizer is actually kind of tough to do, and we thought it would be useful to see how those axes would end up actually affecting learnability and what are the axes that matter for learnability. Does that answer the question? Maybe. We can circle back around to it in the discussion time if there's still more that we want to push on there. Okay, so at this point, we've sort of divided the kinds of research questions that we might be asking into these three categories. And for the particular question that we were tackling about what makes synthesizers easy or difficult to learn, we saw this as primarily a need-finding study. Now, tying in very directly with the last question we got, we actually did end up getting a bit more out of it, and we will circle back around to that later. But basically, the way we saw this work at the outset was thinking about, okay, based on the kind of synthesizers that already exist, that are already out there developed, what are the problems that people run into when they try to use them? What are the lingering needs in this space? Like, based on looking at how participants actually used the synthesizers that already exist, we were hoping to figure out, okay, what are still existing problems? What might be gaps in this space? And so the study overview comes down to bringing in about 20 novice programmers. Again, these were folks who had taken a particular computer science class, so they actually had quite a lot in common with each other. Uniformity can be both good and bad in a context like this. Definitely something we can chat about. We had chosen 5 synthesis tools from the existing literature based on being publicly available, being fairly polished, representing different points in the design space, and therefore potentially producing different sort of patterns in how people use them. And we had 3 tasks per tool, and then we basically watched users do the tasks. And at the end of that, we actually sort of looked through and identified patterns and user needs. So what was coming up again and again? What was actually seeming to make these tools more learnable versus less learnable? Here's where I'm going to go into my unhinged need-finding rant. I do apologize in advance to those who are not need-finding fans, but y'all have given me a soapbox, so I'm going to now briefly rave about how amazing need-finding studies are and how it's so cool that crazy research problems just fall into your lap. That is wild. You go out there, you observe a bunch of people, and then you see, oh, that's a problem. And I never would have thought of that myself because I don't have that problem personally. This ties into something that we've been talking about throughout the week about, how your users may be different from you and how that can actually end up representing something really interesting for how you choose research problems. Okay, so this is my slide that I actually present to usually grad students on PL need finding in a sort of a special topics class. And we talk about basically what we do in the context of PL need finding, which is usually watch a participant using their current programming tools and asking questions like, where do they struggle? Where are they getting frustrated? Where do they do things that are actually quite different from how I would expect them to do things? This is especially relevant in the context of watching novices or watching people who would call themselves non-programmers, because we're looking at it from this perspective of an expert, and we would expect people to do things a particular way that maybe we've been trained to do them or that we've figured out over many years. Where are they actually diverging from that process? And then where do they have to actually leave their normal programming environments and go look elsewhere or use an extra tool in order to figure out how to keep advancing? Where do they have some kind of established workaround for a given issue, right? Sometimes they're going through something, they're like, oh yeah, when I do this, I always have to go over and, copy this code, paste it, right? Like, you'll see weird stuff about the sort of gaps that they have figured out, and they've figured out how to actually work around them. Please.
Can I just point out, because we have lots of students on this call, there's interesting parallels between the process you're describing here and some of the cognitive CDN issues that Luke mentioned yesterday, and you can see some of those as abstractions of these proceduralized.
100%. And another way that we can actually integrate the cognitive dimensions of notation is often we think about how the CDNs actually vary based on the kinds of tasks that we're doing. And so if you're actually assigning participants tasks, right? So in contextual inquiry, that's a particular approach where you're really just coming in and watching people doing their work. But another way of doing observational research is you are actually maybe assigning them particular tasks. And you can actually assign them tasks that are likely to reveal sort of those different sides of the cognitive dimensions of a notation, right? You can ask them to, write code here versus read code here versus edit code here, right? So there's all those kinds of things that we can do to try to get a more complete tour of how these tools actually affect programmers. But yes, absolutely, these tie in really directly with the cognitive dimensions of notation. Okay, and so in addition to asking people to use programming tools with which they are already familiar, we could also give participants a new programming tool or a particular programming tool that has already been developed and ask all of these same questions. This is great for learnability needs, right? If what we're trying to do is figure out, okay, the first time they see it, oh yeah, Hila, please.
Okay, so there's two need finding questions that have come up on Slack.
Yes, I love need finding questions.
Kim is asking, is it reasonable to do course need finding research by looking at in places like Stack Overflow for the indication of where people get stuck?
Yes, I love this. Yes. So one of the ways of doing this need finding research is by looking through, okay, let me actually watch programmers doing stuff. But there are a ton of other sort of records that exist out there in the world about sort of the processes that programmers have gone through. And actually, I would say it's probably more common at this point to do need finding by looking through Stack Overflow posts or forum posts, that kind of thing, rather than by doing observational studies. And this is super important. This has produced a lot of the more important sort of benchmark suites of sort of tasks that we actually care about in this space. So yes, that is a great way to get data. You can look at GitHub and you can see where bugs were introduced. You can look at classroom forums. There's all kinds of things that we can do in that space. I love that question.
Another way to put what you said is those are also ways of watching programmers doing their stuff, right? It's like that's the thing. It's just lots of ways of observing now. Previously, we didn't have.
100%. And one of my recent favorites is actually so there's Twitch now, right? And a lot of times people on Twitch are streaming themselves playing games, but a lot of times they're actually streaming themselves programming. Like we can just watch a bunch of live programming sessions out there in the world that are just public now. There's all kinds of great sources for this information. Yeah, it does not have to be bringing people into the lab. I love this question. I might even have a slide on this later. I'm not sure.
And Matt is also asking, in need finding studies, how do you figure out what is in scope for the user to use if they're, say, learning to use the tool? What are you watching for? If they're Googling, should they be reading the first result? And so on.
I love this question. So a lot of that varies based on the research question that you're actually asking. So I almost put in my second unhinged rant on how you have to always start user studies with a very specific, concrete research question. But basically, if what you want to do is figure out, okay, I want to know how people would use this tool in a realistic, real world setting. Okay, you probably shouldn't be constraining what users are doing. You should probably go ahead and let them go out and do whatever they would do if they were on their own. On the other hand, if what you want to do is figure out, is my documentation sufficient all on its own, such that people wouldn't need any other resources? Okay, then you should probably actually constrain them to only be using your documentation and go from there, right? So it really just comes down to apply the constraints that make sense for the particular research question you're trying to answer. Hopefully that answers that question. Cool. Okay, so in addition to watching with the current programming tool, we can give them a new programming tool. We can give a participant similar tasks with multiple different programming tools. That's the basic approach that we're going to take for the study we're discussing today. I also briefly mentioned that you can actually attend meetings of, like, if you're working especially with non-technical domain experts, right? I put this in because I work a lot with non-technical domain experts. It can actually be really, really useful to attend their working meetings. Even though it seems kind of boring and weird at first, it actually gives you a lot of information for abstraction design, because you're learning about what concepts, what information, what data they find it easy to, like, pull to mind and start talking about versus which are hard. They can say something about what kind of goals they have that they haven't actually been able to tackle yet. And you can start working towards, well, okay, why haven't they actually been able to try those goals yet? That's really interesting. And so that kind of thing is very useful for working with non-programmers. Okay, I'm going to go ahead and move on from this slide unless there are still things coming in. We can definitely circle back around in discussion. Okay, so since we're sort of feeling out what actually is this need finding thing, I also wanted to very quickly talk about what it is not. In particular, the fact that it is not about coming up with solutions, right? That is not our goal when we're doing a need finding study. This is not part of the brainstorming process or the problem solving process. This is just for finding the problem in the first place. And so we definitely don't want to be asking the user to be the designer, right? Like, that's what you're there for. You're going to do that later once you've figured out what the problems are. We're only looking for problems to solve. And it's also not necessarily asking participants about their needs, which is not to say that no one ever does that. Definitely people will do the thing of asking participants about their needs, but that's not the only way. And so this may be a little bit surprising. So let me talk a bit about show, don't tell. So why are we doing this? Why are we talking about show, don't tell? Well, basically, we want to structure our need finding interaction, whatever it is that we are doing in our study design, so that we are observing user problems rather than relying on them to report to us. And there are a lot of different reasons for this, but I'm going to highlight a few. So one is we could mistrue things, right? Especially if we are working with, programmers who maybe don't fully understand the space of language design or the space of tool design, which is going to be most users. They don't necessarily know their needs. There are some that we could observe if we were watching them that they would never notice themselves. They would never think to report to us. It's actually quite common that you'll go in and you'll watch someone and they'll say, oh, this is a thing. I haven't put in enough time working on the weekends doing this manually. It's not a programming. And you'll be like, what? No, the programming task could absolutely help you handle this. This is a huge need. So this kind of thing is super common. We can also learn false things. So one of the really just startlingly reliable results in psychology is how unreliable memory and introspection are. And so, we have this problem too. It's not just that the participants are having this problem, everyone is having this problem. And so it's very easy to learn false things if we just ask users to tell us what they need. But also we can understand true things, but poorly. So it's really easy to come away with sort of a shallow understanding of a need, right? So it's really easy for us to go from, seeing lots of concrete instances of a need to, okay, here's the general category. It's much harder for us to hear, this is a general category of need, and then sort of map that down to concrete things, just because humans aren't that good at doing this mapping from general to concrete. Okay, so this is why I basically try to push that our #1 need finding tool is observation. Watching participants do their thing. And this really enforces that show, don't tell idea very, very naturally, which is why I actually try to suggest, and here I'll introduce this contextual inquiry term, although I briefly mentioned it earlier. This is basically just let me go in and watch users doing their thing. Whatever it is that they are doing for their work, let me watch it. And so that's usually a good starting point. I mentioned here that the global pandemic can sometimes get in the way of this, but actually a lot of this you can do by doing Zoom sessions and just watching what they're doing on their computers, since we do happen to be in this space of programming tools and programming languages. It's harder if you're in another space for sure. Okay. Oh yeah, so this gets to that question from before. How do we actually observe people to find programming memes? So in-lab observation is sort of the main area that I was mostly talking about earlier, but also you can find logs, whether it's Stack Overflow, GitHub, whatever. You can actually instrument a programming environment so that it's sending data back to you. Don't be creepy, but you can get a lot of information that way. You can actually instrument test infrastructure for various courses, if that's applicable, if you happen to be working specifically with students. The various streaming services that now where people are actually streaming themselves programming. If you have more ideas, definitely feel free to throw them in the chat. All right, now I'm going to wrap up my need finding rant because we're getting pretty close to the end. This is not to say that this approach is super mainstream in PL+HCI. I know this is not popular with everyone, and it is gaining acceptance and popularity, I think. But it's okay if you personally are not into need finding approaches. This is not the only way to do it. My personal favorite thing in general is tool building, and so I often do really quite casual need finding work. And then once I've done that, I will go ahead and dive right in on tool building. And this has also produced really cool work that I'm really proud of. So this is not to say that everyone needs to be doing formal need finding research, just that it does end up producing a lot of really cool research problems that you wouldn't necessarily find without it. All right, ending the rant. Back to what we actually found. Let's take a very quick tour through just a sample of some of the themes that we found when we were analyzing user needs in the context of giving them a bunch of new synthesizers that they had never worked with before. So one of the things I mentioned was that there hadn't been really nice characterizations of kind of the space of things that synthesizers could be doing as relates to sort of the user's interaction with them. We didn't really have this idea of what are the user interaction models that are possible for synthesizers, or at least obviously we had a good idea based on seeing many different synthesizers what is possible, but we hadn't really categorized them in any particularly useful ways for this process of user interaction model design. So I'm going to present a couple of sort of axes that we noticed that seem to be really important to whether these tools were learnable for folks. So one is this idea of voluntary versus incidental specifications. In voluntary specification tools, the user basically has to exit whatever they're normally doing with the tool and say, let me go into the synthesis mode where I will be building up a specification, and then you can go ahead and run the synthesizer and give me back whatever results. Whereas in contrast, there's this incidental specification mode where whatever you would normally be doing in that tool, that is actually producing the specification behind the scenes, just as a side effect of normal use. So actually that flash fill example that we saw earlier, where you were just filling out cells, you could take that as an example of incidental specification if what your plan was originally was to fill out that column of extra cells manually, right? So that just ends up turning out to be the specification down the line. Or if your tool is actually sort of auto-suggesting code that you could be filling in, probably some of you have heard of Copilot, right? Say it's automatically suggesting code that it could be filling in based on whatever else you already have in the window. That would be an incidental specification. And it turns out that both of these tools can definitely work for users, but it does seem like for learnability purposes, incidental specifications were a bit less confusing to people. And then there's this other thing about who's actually deciding when the synthesizer runs. This was sort of a weird one, right? So we didn't really think about how this would affect user experience, at least in our prior synthesis design processes. But it's a big difference whether the user is deciding versus the synthesizer is deciding when the synthesizer should actually run, right? So when do we have enough spec that we're ready to go? It turns out it's quite tough for first-time synthesis users to know when they've actually made a good specification. If they have to decide when to run, oh, that might run into some trouble. They might go for 20 minutes before they decide to start trying. And I'm sort of being a bit vague and a bit high level about these lessons because these aren't really sort of the main takeaways from this talk. But I definitely recommend taking a look at the paper to see some of these sort of more low-level things, right? So here I call out one of the design opportunities we figured out here, which is that one of the issues with the user triggering synthesis is that novice programmers will construct sort of wacky, incorrect theories about when to trigger synthesis, right? And so you might want to consider figuring out what are those misconceptions that they're coming up with and try to balance this out, deal with those in your design. Question, yes?
I'm also trying to understand the balance between their perception of a good spec and the actual quality. I imagine a naive view is these are correlated, but they could be like completely uncorrelated.
Yeah, and so we learned a lot of that. I'm actually not going to dive super deep on that one, but yes, this was a huge thing. And one of the trends in particular was this belief seemed to be very common that bigger specs were always necessarily better. But yeah, we discovered a number of sort of wacky folk theories about what would be a good spec, and in general, just a lack of understanding of what would be a good spec. Yeah. Yeah, and some of this gets sort of communication of synthesizer results and using those synthesizer results in order to actually tell the user something. Like one of the wacky things we found, I'm going to get into this really briefly in a moment, was that they didn't always even necessarily understand if the synthesizer had made progress, right? Like there were times when the synthesizer had made progress and they thought it had not, and there were times when it hadn't and they thought it had. So it's really tough for sort of new users navigating these interfaces. Okay, so we talked just a moment ago about who is deciding when the synthesizer actually runs. There's this additional element of this, which is who's deciding when the synthesis outputs are shown. So there are actually some tools that, you know, the synthesizer is deciding in the background when to run it, but they still don't actually automatically show the outputs, and the user is actually in charge of saying, okay, go ahead and show me the outputs. And it turns out that actually doesn't seem to help the users that much more relative to, right, like if the tool is deciding when to run it for them, that can be very helpful. But if the user is still in charge of, you know, pulling when they want to actually see the outputs, then they're not really getting the advantages anymore. Sure, question.
One of our participants named Elena wants to know, is there a citation we can point to about incidental specification?
Yes, so this is coming out in this year's WIST. So that is going to be, yes, this is going to be available super soon. And if you want to like see the paper behind the scenes, just email us. Yeah, definitely. Okay. I think this is the last one probably that we're going to discuss in any amount of depth, just because it's sort of especially relevant to sort of the contents of this talk. So specification size turned out to be sort of an interesting one for us. So a couple of us come from this program synthesis background where we spent a lot of time in sort of PL land and thinking about program synthesizers from that perspective. And in that space, designing for small specification sizes is an incredibly popular goal, right? Sometimes it is even explicitly stated as a guideline for the synthesizer design. This turned out not to be that big a deal for learnability. I mean, definitely like users did like small specs. It was really delightful to them when it got it from just one example or a few examples. This was something that they definitely liked. It just wasn't as big a factor as those other things that we already discussed, right? And so this is quite interesting, because if we had tried to just study the size of the specifications in isolation, the only thing we would learn is that smaller sizes were better. But because we were doing this observational approach, this need-finding approach, instead we were seeing that, yeah, smaller specification sizes were better, but there's all this other stuff that is actually having a much bigger impact on their experiences getting up and running with these tools. And so one of the big things that we can get from need finding is sort of this rough sense of relative importance of different problems, and that can be really helpful. Yes, please.
I'm just wondering, so first, Josh has a question. Does the importance of spec size depend on whether the specs are examples or propositions?
This is a great question. So I would suspect so, but from the context of just this need finding problem, it's too soon to say, right? Like we didn't have enough information to make that kind of conclusion based on just the set of synthesizers that we were actually studying. But if you're interested in studying that question, let's chat, because I think that's a really cool question. Yeah.
So another question, and I don't know how much you want to wade into this controversy, but it is a summer school. We've been talking about different research methodologies, and we've seen sort of this RCT versus other paradigms. And I feel like one could read into what you've just said on the slide, that had one taken an RCT approach and taken this one variable at a time, we would have missed these interconnections between these points. And in particular, you could have taken spec size very clearly is obviously a research question coming from prior assumptions of the community, but by not doing that approach, we've actually learned something more. I don't know. You don't want to put words in your mouth.
Yeah. No, I think this makes total sense. Like, I definitely think that within sort of right, one of the things we've talked about is that RCTs are fantastic for answering really nice, narrowly defined research questions, right? And so if our research question is Is it better to have small spec sizes versus large spec sizes? And RCT makes a ton of sense for answering that question. On the other hand, if our question is basically, what is the most important factor in figuring out whether a synthesizer will be learnable? It's really tough to design an RCT around that, because first you have to have some hypotheses about what might be the most important factors. And so coming up with that sort of list of important factors, that's probably never going to be the outcome from a randomized controlled trial. And so that's sort of basically just about the different roles of need finding versus, or observational research versus randomized controlled trials. Yeah, I just think they serve different roles. Okay, there were some other fun lessons about learnability. I'm going to skip through those because we're running out of time, but a couple of these we actually did already mention. So we mentioned that participants were struggling to understand synthesizer progress and what kind of spec is actually useful. We will skip over this as well real quick because we are again running out of time, but I'm going to highlight a couple of the kinds of future work that I think would be really interesting based on the findings from this paper. There are many plausible great answers here. I'm just going to highlight the ones that I'm personally excited about following up on. So I mentioned the relationship between this kind of research and something more quantitative, something more like randomized controlled trials. One of the things you could do at this point is say, okay, these were some really interesting patterns they discovered. Let's see if they hold up when we actually submit them to randomized controlled trials. What happens then? Do we see a real effect or an interesting effect from changing a synthesizer from user triggered to automatically triggered? That kind of thing can be really, really interesting and is a great way to actually follow up on this kind of study. We can also use this as an evidence, right? Like this was a need finding study. We can use this as evidence of gaps that are out there in the program synthesizer space and actually start designing synthesis tools that will fill those gaps. We can also actually, do sort of wacky stuff designed to stress test these patterns. Like, can we design a synthesis tool that really pushes these to the extreme and see if we can keep going, right? So there's really fun stuff that we can do once we have sort of figured out these patterns. Okay, I want to real quick talk about publishing and then I promise I will wrap up. So at this point, results were in. Looked like there were going to be some useful lessons for the community. So let's go ahead and submit. One of the interesting things here is that quirks of timing can play sort of an interesting and surprisingly strong role in submission decisions. So at this point, the master's student who was going to be graduating was pretty interested in getting these results out there. The WIST deadline was coming up before the CHI deadline. Okay, seems like a good opportunity to submit to WIST. This was also actually a good reason so this was a good idea for other reasons, specifically like a lot of the people who are actually building interesting new program synthesis tools are publishing at WIST, and so this is a venue where they're already reading, and so getting these results in front of the WIST community would be really great for that reason. But also, like, this is kind of a weird mismatch with the usual vibe of WIST, right? Because often what you expect to see at WIST is a new tool is introduced, it has a really exciting demo, there's some kind of really interesting user interaction that's happening in that demo, right? That's the kind of thing that we would normally expect to see there, whereas this was standalone need finding research, right? There was no new tool introduced, there was no exciting demo. And so I'll be honest, I was mostly expecting that this paper was going to be rejected from WIST. I was not really expecting, I thought we'd get some interesting and great feedback, and then we would probably go ahead and resubmit to some other conference. But in the end, this was actually accepted at WIST. And I think this is actually really interesting evidence of how the community norms and the accepted modes of research are changing in this space. So I think the sort of openness to need finding research is really increasing, both at, technical HCI venues like WIST, but also actually over in PL land. So actually one of the authors on this work had just the year before gotten a standalone need finding paper into UPSLA, which is a PL conference. So this kind of stuff is becoming, I think, increasingly accepted, where you really can be submitting this kind of research, this kind of work to venues that previously wouldn't have been super open to it. Shriyang.
Well, I also, again, from a summer school point of view, I was hoping to just draw a contrast to what happened on day one, right? Where Philip was, in some sense, Philip had done his own kind of maybe more informal need finding about incrementality. And he pointed out, like, felt he could not submit, or maybe got rejected from WIST-like conferences because of the lack of a new UI, when that was kind of a feature, but was treated as a bug. And you don't have a new UI, but perhaps I wonder if your work maybe was also viewed as it could lead to a new UI, versus Philip was like doubling down on like, we don't want a new UI. But it's just interesting to see that in 10 years time, like things are changing. for the better?
I do think things are changing. Yeah, I think we are seeing a real shift in the culture and the acceptance of this kind of work. That's been my impression from looking at the change over the last 10-ish years.
Yeah, I also want to point out it's funny, like stepping back, thinking about both of us have kind of have found a lot of research productivity in this intersection of PL and HCI, but in dramatically different ways. In that you are publishing need finding studies at OOPSLA, which is like, existence proof that that's possible, right? As well as at WIST, which is the most technical, of the top tier HCI conferences. And I, coming from HCI, right, kind of taken the productivity of kind of like, oh, here's this really cool technology the PL folks have created. What are the like low hanging fruit in terms of like interaction design that I can add to it to make it more usable, that kind of thing. And so it's really nice that we have people in both directions, essentially. So we don't just have a single direction in terms of two fields helping each other.
This is one of my favorite elements of this intersection space, right? The fact that PL techniques can be super useful inside HCI and the fact that HCI techniques can be super useful in PL. I love this element of this work. Okay, I think I'll bring us into sort of the wrap up. Okay, I do want to briefly talk about, we've been talking about sort of the fact that it is sort of wacky for people from kind of a PL background to be doing this kind of need finding work, and it can be a bit weird. So in particular, the day-to-day could be more fun or less fun for any given individual. I tend to work with students who are really keen on working on tool building, and so often for them, it's actually a bit less fun, and that can be quite stressful to spend some time doing. I mean, it's usually incredibly interesting, and their time in the sessions are incredibly informative, and they feel like they're learning so much, but they kind of miss being in the code bases, and that's totally natural and unfair. But it changes sort of some other elements of the day-to-day, right? So like if you're doing tool building, you've already done a bunch of good need finding, so you've picked a really important problem, then often you're having a lot of these conversations where people are saying, oh my gosh, thank you so much for working on this. I'm so glad someone is finally tackling it. So this is like really amazing. And it's always kind of building you up, right? And so when you are instead doing this need finding work, instead of the tool building work, you're not getting those thank yous, that sort of gratitude that can be like very motivating and really keep you in the research zone. But then in the long term, you are signing up to have a lot more of those people saying, oh my gosh, thank you so much for working on this. This is a really huge deal for us. So it can change the day-to-day in really interesting ways. All right, I'm sorry. I know I ran over. I'm ready for discussion time now. I'm really sorry for all of the.
No, it was great. That was absolutely amazing. So we're going to follow tradition. We're going to do breakout rooms. So in the interest of time, let me get that started as quickly as I can. Okay, so questions. Questions for Sarah. You can type them in. I see people are already typing. Okay, so Matt has a bunch of questions here. How does lesson design work in examples like this? For example, if the lesson was really good, maybe you didn't need a synthesizer. The lesson was confusing, maybe synthesizer won't help. And should the synthesizer be designed for the lesson? Should the lesson be designed for the synthesizer, etc.? Wonderful collection.
I love it.
Yeah.
Yeah, I love this question. So this is actually, I would argue this was probably the hardest part of the design of that study, because writing teaching materials of any kind is incredibly hard. And it's hard to know if you have done well. Basically, the way that we planned to short circuit that was, okay, if the lesson plan sort of on its own with manual writing doesn't actually improve learning outcomes, well, okay, it's probably not a good lesson plan, right? Because we were doing this pre-test post-test thing, right? Like, how did you do on the concept inventory beforehand? How did you do on the concept inventory after? But like, yeah, it's really easy to write a lesson that doesn't really help that much.
Harry Goldstein, I wonder if this question is maybe a misunderstanding. It's like there was some wording lost here. So can you talk a bit more about the very, very good reasons to not use contextual inquiry? And in particular, Harry adds, I'm currently working on an interview-based need finding study. We think we have solid reasons for that. So I'd like to check against your intuition.
Okay, yeah. So I think this comes from the bit where I was like, okay, like unless you have a super good reason to not be doing contextual inquiry, like please go ahead and try contextual inquiry first. I think it's probably from that bit. So that's sort of an instruction that I normally give my students, right? Like when I'm the advisor and I'm working with someone And if they're saying, you know, I really want to do this as an interview study, or I really want to do this as whatever, like normally I'm going to try to push them in that direction of, okay, let's instead do observational first. And maybe there will also be, maybe we'll also augment it with interviews. But so one example of, you know, a reason not to do it observationally is, you know, say they are working with sort of a large lab space, right? And they have to be sort of moving all around and doing stuff in the physical world, right? Like say this is a weaving studio and not some kind of programming task, right? Like, and it's a global pandemic, right? Okay, you're probably not going to be going into the weaving studio and following them around during that situation, right? So that would be a really good reason to not actually do it observationally. And sometimes there are obstacles like that where it's just, for whatever reason, it's not safe, it's not practical for you to go in and be observing them. But except in those situations, I really would always tend to start with observation. I mean, maybe you also want to ask some interview questions. Like maybe you have some research questions where you feel that those research questions can't be answered over the course of, you know, one day of watching someone work or 2 hours of watching someone work. That's a good reason to try to look at some other approaches. But in general, if you think you could be learning some of it from observation, I would recommend trying to learn at least some of it from observation.
Could I
Hope
throw
that
in like
answers
one or
that.
two more reasons
Please.
why not? So you might be working, there might be trade secrets involved, right? You're working with a corporation that does, you know, they're working on Microsoft code base, or they're working on financial products. And so they're not going to want you to see that code. The other thing is you might be asking them about why they don't do something, and then it's impossible to observe, right? So, and Harry's smiling, so yes. Okay.
Well, or you might be asking them about sort of emergency things that come up and like, how do you time it so that you see the emergency, right?
Yeah,
Like
exactly.
if this is something that happens once a year and you want to know how they deal in that. And
Bingo, bingo,
Yeah.
bingo. Yeah. Sorry, right. So we're understanding that this is not blanket advice. Just think this through and make sure you understand your reasons. Yeah.
Yeah.
Or
Start from this as the
you can
default.
cause the emergency. You can always like infiltrate them.
Elijah suggests inducing an emergency, but
Right. Okay, so Josh has a question here. Let me just quickly see what Justin's response. Justin says, I found that interviews right after an observational session work super well because it keeps the conversation very grounded. Right. Right. Okay. Josh says, what is your perspective on need finding as a theory building technique? Example, to what extent should need finding help us define the design space of synthesizers versus just uncovering problems and the relative importance of problems for synthesizers?
I love this question. So I think this is basically a great way for coming up with hypotheses for theories, right? Like absolutely build the theory from that, but we don't get to then just blindly accept the theory, right? Like once we have built up, okay, it seems like this axis matters. It seems like this axis matters. It seems like we, you know, see more success when we do X, Y, Z, right? That's a great set of hypotheses. Go out and test those. Then we can trust that that's good theory. Yeah, I love that question.
Could I also add, Josh obviously knows this, but for some people that may not be, it may be news, there's a whole concept of what's called grounded theory, right? And grounded theory is, as opposed to sort of, it came about as kind of a critique of the classical textbook version of the scientific method, right? You generate a theory, you generate an experiment. Grounded theory is, let's go look at what's going on out there and just figure out how to synthesize theories from that. And there's a whole set of techniques in grounded theory to enable you to do this. So if you have these kinds of issues, definitely go look up grounded theory. It comes out of social science, but very relevant to us, right? And Josh is obviously tickling right around that question. Kim,
although importantly, don't try to do that after you've already collected the data. This has to actually affect how you collect the data, so be careful.
Right. No, I mean, there is a bit of a loop there too, right? Because you often do grounded theory, after with some data, then that, et cetera, et cetera. Yeah. There was an interesting comparison of 0% synthesizer use versus 100% synthesizer use. There are tools for which obviously partial synthesizer use is possible, such as ReSharper, Rust Analysis plugin, et cetera. And how do you think those fit in? And is that a good space for further research?
Yeah, I'm super interested in further research in this space. So obviously, Justin, one of the authors of this paper, is now on, so he can chime in if I get anything wrong, but I'll take a first pass at answering this. So one of the things that we found, you know, we talked about the fact that incidental specifications were super helpful for people. One of the reasons is that people were really trying to use sort of their other ways that they know how to communicate their intent, right? So one of the other ways, these were novice programmers, they were people who had been programming for up to about a semester. One of the ways they know how to communicate their intent is by writing programs. And so often what they wanted was when they saw, okay, this synthesis output is pretty close to correct, not quite there. Let me just go in and tweak that. And if the synthesizer wasn't giving them the option to do that, that was very frustrating. And so sort of using it as this, almost as a drafting tool, and then they're going in and messing with it, or going through the process of, writing code in their normal way. And then that's a big part of the specification rather than just some other mode of switching, right? Like they like it when they can also be doing other things to communicate their intent. And that includes programming. So yes, this is a super interesting space, and I definitely think there should be more work there.
Cool. Other questions? I think we've also had a whole bunch during the talk itself, and it was a wonderfully interactive talk. So, okay, I think we may be ready to wind down. In which case, I guess on behalf of the organizers, we can all speak for ourselves. But I certainly totally loved having all of you here, especially those of you who came all days. It was so great for you to take out this much time and come, and got to meet new faces, see some old friends as well. So thanks so much for coming. I hope we'll end up doing more of these in the future. And Hila, Elena, Sarah?
Huge thank you to everyone. This was super fun. Today was extra fun for me, but all of the days were super fun. I had a great time chatting with you all.
Yeah, no, I really appreciate the collective effort of the organizers to make this happen, despite, so much going on in the world. And I'm really grateful that it came together so nicely. I also very much looking forward to directing those who couldn't be here to the recordings, which will be posted. And there may be a survey, perhaps, of people who are able to make it at least one day, so that we can figure out what you liked, what you'd like to be done better, because I do hope that we get to do this again in the future, and constant improvement is the name of the game.
Please give us feedback. We're all about user-based methods. So, Hila?
Yeah, thank you everyone for coming, and thank you for all of your great questions. Once we got you to open up and start asking them, you've been terrific audiences for all of our speakers. And, when we do this again, do come back.
And tell your friends about it. Yeah.
Yeah, definitely. And I think with that, one last time, we can hand it over to our social directors.
Yeah. Thank you so much for doing that. All right, everybody.
And a big thank you to the social directors. Yeah.
Yes, thank you both. Yeah. Bye-bye.